Okay, let's do some problems about the rules of exponents. So for these, we're going to simplify each expression so that each variable in the expression appears at most once with a positive power. So for example, in this one, we have a here and a here. I'm going to bring those a's together. And we also have this negative power here. I'm going to make it so that a has a positive power at the end and b has a positive power at the end. And that might mean I need to move them to the top or the bottom. All right, so there's usually more than one way to do these problems. You can have some choices about what order to apply rules in, but you do have to apply the rules correctly. So the first thing I see is that I have something to a power, and then that's being raised to another power. So I'm going to multiply the two powers together. So 2 times -3 is -6. So now I have a to the -6. Over here, I have a cubed and b. There didn't really need to be parentheses around this because it's just being multiplied by this a to the -6 over here. So I'm just going to drop the parentheses. This is called the associative property of multiplication. It doesn't matter which pair of factors you multiply together first. On the bottom, I'm going to apply the rule about raising a power to another power again. So this will be b to the 12. Okay, so now I see that I have a to one power and then a to another power. So when I have that, I can add the two powers together. So -6 plus 3 is -3. And over here, I have this one. It might not be so obvious to you how to simplify it. You could do the thing where when you have something to a power divided by the same thing to a different power, you do the top power minus the bottom power. So you could make this into b raised to the 1 minus 12, so -11, like this. That would be one way to do it. Another way to do it would be to realize that you have 12 b factors multiplied together down here, like b, 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 12 b's. And then you have 1 on top, so 1's going to cancel, and you would have b to the 11 left on the bottom. Either way you want to do it is fine. Maybe I'll just kind of do the more standard, like, subtraction technique. Okay, so now we have nothing in the bottom, just a 1 in the bottom, and we have negative powers up on the top. So when you have a negative power, you know that when you have something like a cubed, that means multiply a together 3 times. So what does it mean to multiply a together -3 times? How do you multiply something a negative time? So what it means is to do the opposite of multiplication. In other words, divide, or multiply by the reciprocal. So a to a negative power means the reciprocal of a that many times. Okay, so this is the same as reciprocal of a cubed, and then reciprocal of b to the 11th. Or you might just remember that there's a rule of exponents that says when you have a negative power in the top or the bottom of a fraction, you can push that power to the opposite place, like from the top to the bottom or the bottom to the top, and then switch the sign of the power. So if you remembered that, then you could just make this into 1 over a cubed, b to the 11th, which is the same thing that you get over here, because when you're simplifying a fraction to a power, the power can be distributed over the top and the bottom. So you'd just have 1 cubed over a cubed times 1 to the 11th over b to the 11th, which is the same as this. All right, so this is going to be our final answer because we were asked to make sure everything ends up with a single copy of the variable, so 1a, 1b, and then positive powers. Okay, next problem. So 8r to the 1/2, now we have fractional powers. S to the -3 over 2 r to the -2, s to the 4th. Okay, so first thing, make sure you realize that the 8 does not have this 1/2 power. So the order of operations is PEMDAS, and that means exponents go before multiplication. So the 8 is attached to this r to the 1/2 with multiplication. So only the r gets the 1/2 power. All right. Next thing, you could go ahead and cancel a factor of 2 from the top and the bottom. So if I take a factor of 2 out of 8, this leaves me with 4 instead of 8. So, and then this 2 is just going to cancel. So if I do that first, then I have 4r to the 1/2, s to the -3rd, r to the -2, s to the 4th. Okay, now I can kind of just do what I did on the last problem where I'm using the subtraction of exponents rule. I think that's what I'll do. So so the power of r that I have is 1/2 in the top, -2 in the bottom. So I'm doing 1/2 minus -2. Be careful that you're subtracting the -2, because that's going to turn into addition. And then for s, I have -3 minus 4. Now I'm going to simplify those exponents. So this will be 4, 1/2 plus 2, so 2.5. So I guess you could write it as like 2.5. I guess I never specified that you couldn't have a decimal in your powers. So if you didn't want to do that, then you can make like a little sidebar and try to figure out what's 2 plus 1/2. Get a common denominator. Multiply 2 by 2 over 2, so that's 4 over 2 plus 1/2, 5 over 2. So you could do that in a little sidebar. Anyway, you get 4 times r to the 5/2, or 2.5. In math, whatever's not forbidden is allowed. So if they didn't say no decimal powers, then I say go for it. 2 decimal powers. Why not? And then for s, we have -3 minus 7. -7. Okay. And now I was told to finish up with only positive powers. So I'm going to take that s to the -7. I'm going to send that to the bottom. In other words, I'm going to write it as division. So -7, this means unmultiply by s 7 times. So what I'm doing is I'm dividing by s 7 times. That is the meaning of the negative exponent. And nobody told me that I had to write this with like roots or anything. They just said positive power. So I'm going to stop right here. And let's do one more. So the last one is the most tricky one, I think. AB parentheses AB squared over 2 A cubed B -1, and that's all raised to the -2. Okay, so let's start applying some rules. I'm just going to not ignore, but I'm just going to drag this AB along and just keep copying it and not worry about simplifying it until I've simplified this beautiful mess over here. So there's a few ways you could start. Since we have a fraction raised to a power, I think I'm going to do what I did up here and just distribute the power to the top and the bottom of the fraction. So yes, exponents do distribute over multiplication and division, but not over addition and subtraction. Oh, right, I was going to distribute it. So let me write. By the way, if you guys are not using mechanical pencils, you got to get with the mechanical pencils for math. It's the best thing. So I'm just going to write the fraction, or sorry, the top of the fraction. Said I was going to just drag along AB, sorry. The top of the fraction to the power divided by the bottom of the fraction to the power, like this. Okay, and then my next step I think I'm going to do is distribute this -2 power to the factors inside of here. Okay, I could do this faster, but I'm just going to take it step by step so you guys understand everything. Okay, so I'm going to have a to the -2, and then be careful here because this is actually 2 factors of b. This is b times b. So I'm going to keep it as b squared and then have the -2 power on that. Okay, and then on the bottom, so I've got the 2 factor, the a cubed factor, and the b inverse, or the b to the -1 factor. Those are all going to get the power of -2. So the ones that already had a power, I'm going to use parentheses like this. Okay. And the reason why you need a mechanical pencil is because this little powers get so small that if you're writing with a regular pencil, you would have to take up like multiple lines to make the characters bigger to be able to read them. Okay, anyway. Right, so now I'm going to apply the rule where when something is raised to a power, and then that's all raised to another power, we multiply the powers together. So, oh, I somehow like forgot myself, and I said I was just going to drag AB along to the left, but then I went ahead and simplified it by putting it into the top of the fraction. I guess I couldn't stop myself from doing it. 20 years of math will do that to your brain. Just start automatically simplifying. When you're multiplying a number times a fraction, you can just multiply the number into the top of the fraction. Okay, so I'll just keep it like that. All right, so AB, a to the negative 2, and now 2 times negative 2 here is negative 4. And then on the bottom, I have 2 to the negative 2, and then a cubed to the negative 2 is 3 times negative 2 for the power. This is a to the negative 6. And then b to the negative 1 to the negative 2. So negative 1 times negative 2 is positive 2. Is b squared. Okay, and now I'm going to combine factors of a on the top and factors of b. So this is a to the 1 times a to the negative 2. So this is, if I add those powers together, it's 1 plus negative 2. And I'll simplify that more on the next step. And then for b, I have, again, a power of 1 plus negative 4 from here. And then I'm just going to copy the bottom the same. Okay. So now simplifying the top, I have a to the 1 plus negative 2 is negative 1. 1 plus negative 4 is negative 3. Oops, 6 squared. Okay. So now I'm going to use the rule about something to a power divided by the same thing to another power. So if I have an a on the top and the bottom like this, I can subtract the top power minus the bottom power. You see this one is the hardest. I'm already on the third line here. So I'm going to have a to the negative 1 minus negative 6. Make sure you're subtracting the negative number, so that's going to flip it to positive. And then I've got b. So I have negative 3 in the top, and then in the bottom, 2. So negative 3 minus 2. And then this extra 2 to the negative 2 power from the bottom, maybe I'll just leave it here and I'll tell you guys what to do with it later. And there's always multiple ways you can do this. Okay, so 1 minus negative 6 is 1 plus 6, or sorry, negative 1 plus 6, which is 5. And then b to the negative 3 minus 2 is negative 5. And then I still have this mysterious 2 to the negative 2 on the bottom. Okay, so whenever you see the negative power on a factor, you can send that factor from the top to the bottom or the bottom to the top, as long as you switch the sign of the power when you do that. Because this negative 5 here is saying unmultiply by b 5 times. In other words, divide by b 5 times. And the same thing here on the bottom. This is not really dividing by 2 times. It's like, this is really like 1/2 squared, because the negative power means the reciprocal. Okay, so I'm going to end up with 2 to the 2 on the top. Switch the sign of the power. A to the 5th can stay where it is. B to the 5th is going to the bottom. And now I'm going to finally simplify 2 to the 2 to just be 4, since that seems shorter to me. Okay, that's it. Everything has a positive power. That's it.